The metric system is a system that's considered the units that are used in science. The metric system is an international system, and the United States is one of the few countries that still does not commonly use the metric system, although it is slowly creeping into our society. If you're a car buff and you go down to a car parts store, you can buy a set of metric wrenches, because a lot of our automobile parts are manufactured in other countries, or assembled at least partially in other countries. And as a result, these countries don't use measurements like inches, quarter inches. They use metric units. Also, if you look at any packaged food or drink items, you'll notice that they have both a metric and what's called the English system of measurement on them, which is kind of funny because England doesn't use the system. They use the metric system. However, these types of units are the ones that are used in science, and a lot of times we have to be able to convert very quickly from one metric unit to another metric unit in order for it to meet needs a particular formula or something else. So we have to become comfortable with making conversions between the metric system. Now, it's important to note that the metric system is composed of what are base units, called base units, for any quantity or measurement. Okay, and these have a value of, we'll call them 1, value of 1. And then prefixes are added to the base unit. Okay, they either make the unit, make it larger in increments of 10 or 1,000. Okay, or they make the base unit smaller in the same increments. So one thing to note for yourself is that prefixes are never written alone. You're going to see them on your conversion sheet by themselves, but when we actually work with them and write with them, you'll never see a prefix all by itself. Prefixes are always attached to base units. A base unit can appear alone, but a prefix has never appeared alone. A prefix always appears attached to a base unit. Now, you're going to need your metric and unit conversion sheet, and you're also going to need your scientific calculators for this. Okay, this picture right here, this is what your worksheet looks like. We're going to go over some things for you. The first column here is the name of the prefix. The second column would be the letter for the prefix. And the third column here tells you the relationship between the prefix along with a base unit and how many base units that would be worth. Down here are the 3 base units that we'll be working with most commonly. This is the base unit. The gram is the base unit for mass. The meter is the base unit for length. And the liter is the base unit for volume. In chemistry, we use grams and liters most commonly because we usually are measuring the mass of something and the volume of something. Okay, however, if we did have to be measuring length, we would also measure the meter. Now, these are the base units you are responsible for. Okay. This is D for deca, H for hecto, K for kilo, M for mega, G for giga. These are all larger. The farther you go up the sheet, the larger that particular prefix makes the base unit. Down here we have lowercase d for deci, lowercase c for centi, M for milli, U for micro, and N for nano. As you go down, each prefix makes the base unit even smaller. Now, the letters we use for the base unit will be G for gram, M for meter, and L for liter for volume. Okay, so when you see the word base unit on the sheet, the base unit in an actual problem is going to be replaced by one of these letters. The prefix will be added to the base unit. So for example, if we take a look here, it says hecto, and it says 1 hecto equals 100 base units. So if I was working with a problem with hecto, I'd have 1 hecto equals 100 G or M or L. Okay, I would also need to have a base unit here next to the H. So let's say I was solving a problem and it was talking about hectometers. So I would interpret this as 1 hectometer would be 100, and the base unit here is M, so 100 M. Now if the problem's talking about hectograms, then it would be 1 hectogram is equivalent to 100 grams. Okay, so that's how we interpret this information and turn it into a piece of information that will be useful for a metric conversion problem. Okay, down here it looks a little bit different. If you kind of look up here, this talks about 1 giga was 1 times 10 to the 9. Down here, for example, this one says 1,000 millis is 1 base unit. So if I was using millis, if milli was the prefix, let's say that was milliliters, then I would say 1,000 milliliters. In this case, it says that's equivalent to 1 base unit. Okay, well, this is always the base unit, so that would be 1 liter. Okay, so one of the things that you're going to be practicing first is writing these. These are called equalities. Now, they're qualities because they're the equal sign. So students often tend to not understand what's happening when we're doing a metric conversion. When we're doing a metric conversion, we have a particular measurement of a quantity, how much something weighs, how long something is, how much volume something has in a particular unit. In science, we always measure, and there's always a number in a unit. So for example, if I was talking to a person, I said, "How tall are you?" and they said 83. You would have no idea what that meant. You'd say, well, what, 83 feet, 83 inches, 83 centimeters, what? Okay, so a measurement makes no sense if it's just a number. A measurement always has to have a unit. Now, if I was talking to somebody and they said, "Oh, I'm 83 inches tall," and you said, "Well, how many feet is that?" They would have to do a conversion, and they would express their height in feet instead of just in inches. Now that doesn't mean that that's changing their height at all. So even with metric conversions, we're not changing the value of whatever it is we measured. The number is going to change because we're changing the units. Now since metric is a base 10, you can see all these 10s system, the measurement is going to be changed into something that just has, it's going to be some factor of 10 larger or some factor of 10 smaller. And the equalities are what allow us to do that. Alright, so we're going to kind of flip back and forth between this page, because this is information that we need, and some example problems. Now, when you do a metric conversion, you're always going to be given some type of a number. And then you're going to be saying, what is the equivalent value of that in liters, okay, or some other unit? Okay? The base units on each side have to be the same, because if this is a volume, obviously, you have to be asking about a volume. You can't say, well, this is the volume of something, so how much does that weigh? Okay? We can do that, but that's a completely different formula, a completely different type of problem. Here we're just saying, if we measure this volume in this unit, what's the equivalent value of it if we're going to measure it in a different metric unit? There's a particular model that we're going to follow. And some of you may have learned a shortcut method, and you're going to have to let go of the shortcut method, because it's exactly, sometimes shortcuts are good, sometimes shortcuts are not really good. And this is one where it's not good, because you can't really show your work, and you're not truly demonstrating that you understand what it means to convert one unit into a different unit. You have to show work on these problems to receive credit on your homework, on your quizzes, on your exams. And the work that you're going to show me is setting up what's called a dimensional analysis problem. You'll then use your calculator to actually solve for the answer. So when we start with these, the first thing you're going to do is you're going to, underneath the problem you've been given, is you're going to rewrite the number and the unit that you start with. And then you're going to put a line under it, and you're going to extend the line way over. Okay, and then you're going to put a little line here. Okay, so basically you've put this in a box. Okay, it's always going to start in the upper left-hand corner. Now, the next step is we're going to find the equality on our sheet that has to do with kiloliters and the base unit. So now we're going to go back up to our page and we're going to find kiloliters. All right, here it is. Here's kilo. Okay, the symbol K. And it says a kilo is 1,000 base units. Now if you look back at our problem real quick, the base unit in our problem is the letter that's next to the prefix. The base unit is liters. So this is, we're going to be talking about not kilos. Remember, we really don't talk about prefixes alone. We're going to be talking about kiloliters. And that will be equal to 1,000. The base unit in this problem is a liter. So 1 kiloliter is 1,000 liters. So we're going to write that. 1 KL. I'm going to write that above the box. Equals 1,000 L. Okay, now we're going to fill in the top part of the box and the bottom part of the box with the two different sides of the equality. The real trick to setting up dimensional analysis is to determine which side of the equality goes on the top and which side goes on the bottom. In order to do that, we're going to go back to this first box and we're going to look at what unit is written here. Unit written here is KL. We're going to move this unit. We're going to rewrite it in this box here. We're going to move it down we're going to move it down and to the right. Okay, now we're going to go up here, we're going to ask ourselves, okay, which side of the equality has a KL? This side. What number is in front of it? A 1. So we're going to write a 1 in front of the KL. So this side of the equality goes on the bottom. How do we know? Okay, because this unit must appear here. It's called dimensional analysis because when we're done, we're going to be able to just cancel these units out. Just like a variable in an algebra problem. When you're trying to simplify an algebraic problem, you say, hey, if I have a unit on top of a fraction, an unknown, a variable, an x or a y, and I have another x and a y on the bottom, I know I can cancel them out and simplify the problem. We're doing this very similar thing. It's just an application of canceling variables. All right, so what goes up here on the top? Well, the other side of the equality we didn't write down is the 1,000 liters. So we're going to write the 1,000 liters here. Okay, so next question is, all right, I filled in the boxes. What do I do? Now we're going to turn this into a mathematical problem. We're now going to consider this as like multiplying fractions. We're going to multiply across the top. So we're going to have a top and a bottom. Okay. Before we do that, though, let's simplify. Let's get rid of these units. So this KL can be canceled by this KL. Remember, you cannot cancel. You have to cancel this way. The L doesn't cancel, so I still have the L. So now I have 4.95 times 1,000. On the bottom, it's just 1. So now that looks like a calculator problem. So we're just going to get out our calculators. 4.95 times 1,000. That's 4,950. We know that divided by 1. Don't need to do that. 4,950. And we didn't cancel out the L, so we still have to have the L, the units. Okay, let's try another problem. Okay, 17,000 meters. We want to convert that into equivalent number of centimeters. Again, we're going to start by rewriting underneath the problem both the number and the unit, which in this case is m. Okay, we're going to go to it now. We're going to say, okay, well, what do I need from my sheet? Okay, this is just a base unit, but this side has one of the prefixes. This is C, centi. So this problem is all about the relationship between meters and centimeters. So let's go back to our conversion sheet. Here's centi. So centi, it says 100 centis, one base unit. Now we said we're talking about meters, centimeters. So this would be 100 centimeters is 1 meter. Remember, a base unit is always replaced with a G, an M, or an L in an actual problem. Okay, so let's go back down. So we're going to write 100 centimeters is 1 base unit, 1 meter. Okay, now we got to take these, the two different sides of the equality, decide which one goes on top, which one goes on the bottom. Look here and says, okay, it says m. So I'm going to need to cancel the m, so m is going to have to appear here. Which side has the m? This side has the m. There's a 1 in front of it, 1m. So this side of the equality must appear on top, 100 centimeters. Now it's a math problem. Cross out the units that I can cancel out. Okay, the centimeter doesn't cancel, so it's still going to be in the problem. Okay, now I'm going to multiply. This is 17,000 times 100 all over 1. Let's put that in my calculator. That's 1,700,000. And the centimeters didn't cancel, so it's still there. 1,700,000 centimeters. Now, at this point in time, some students say, okay, so you always just put 1 on the bottom. Okay, well, unfortunately, you don't always put the 1 on the bottom. Sometimes the 1 goes on the top. Okay, let's look at an example for that. Okay, so here's our new problem. We have 300 little m. Okay, when it's a prefix is milli. Remember, m by itself means the base unit meter. This is why we don't write prefixes by themselves. If you just wrote 300m, people would assume you mean 300 meters. You mean milligrams. So you always have to write the milli prefix with a base unit. Okay, so we're looking at milligrams. That's the only prefix in this problem. Let's set up our problem to fill in the boxes. So we're going to write 300 milligrams. Line. Okay. All right, here's the milli thing. And it says 1,000 millis is 1 base unit. Now remember, this was milligrams, so it's 1,000 milligrams is 1 gram. The base unit is gram. So let's write that down. (1,000 milligrams is 1 gram. Now, where does which side goes the equality goes on top, which side goes on bottom? In order to tell, you got to start over here. Milligram here, so milligram has to go here. Ask yourself, okay, here's the milligram side. It has 1,000 in front of it, so I have to write 1,000 here. This time, what's left over? The 1 gram goes on top. So if you say, well, how do I know if the 1 goes on top, the 1 goes on the bottom? If you look at your equality, and then look at the unit that you're starting with and say which side of the equality, if I put it on the bottom, would allow me to cancel units. If I wrote 1,000 milligrams on the top, I couldn't cancel out the milligrams. I would be multiplying the milligram times the milligram. Just like in an algebra problem, if you have x times x, that doesn't cancel out x. That gives you x squared. You have to be really careful with that. All right, so I will cancel out the milligrams, and I'll multiply. There's nothing, that's like a 1. So I have 300 times 1 gram over 1,000. Okay, so it'd be 300 times 1 over 1,000. Okay, the calculator says that's 0.3. The G didn't cancel, so that's 0.3 grams. Okay, hopefully so far so good. Last, we're going to look at a slightly different looking metric conversion. Okay, what's different about this particular problem? Well, there's a prefix hecto, and there's a different prefix here. Okay, this little prefix, this is a cursive U, for those of you that aren't very familiar with cursive. And on your sheet, it looks like an italicized U. This is the prefix for micro. Okay, the micro starts with an M, but the letter M has already been taken up by milli. Now, what do you do if there are two different prefixes in your problem? Well, the way you're going to set this up isn't very much different. You're still going to start, but this time, rather than just drawing one line, I'm going to draw two. This first set of boxes is going to be for the first prefix, which is the hecto. The second set of boxes will be for the second prefix over here, which is micro. All right, so now when I go back and look, now I have to look up two relationships. Again, our base unit here is gram. So where I see the word base unit, I'm going to think gram. All right, here we go. 1 hecto. 1 hecto is 100 base units. So 1 hecto would be 100 grams. Let's write that on my problem. 1 hectogram, 100 grams. Okay, and then this micro thing that's down here. Okay, this is a number, this is in scientific notation. We'll talk very briefly about how to put that in your calculator. It says 1 times 10 to the 6 micrograms. Remember, our base unit is grams, so it's 1 gram. So we're going to write that on our paper. Okay, so now that we have these equalities, and we just wrote these straight down from our paper, how do we fill these in? Okay, it's the same process here. Okay, I've got a hectogram here, I'm going to put a hectogram here. Okay, which side of the equality is hectogram? This side, there's the 1, so the 1 goes down on the bottom. What's left over is the other side of the equality, that has to go on the top. Okay, so how do I decide now? I don't want to cancel hectogram. And how do I decide what to do? Well, I have a new unit that I introduced here. Let's try to get rid of it. So let's put the gram down here on the bottom. That way, I cancel this hectogram, I can also cancel the gram. I want to only have one unit left when I get to the end. Okay, which side has the gram? This side, there's the 1, so 1 goes on the bottom again. So the 1 times 10 to the 6 microgram goes on top. Okay, let's cancel out the units that I can. The only unit I can't cancel is microgram. Now let's set up the math. Okay, yeah, now I gotta multiply several numbers together, which gives me. So this is 750 times 100 times 1. I'm going to put parentheses around this, otherwise I'll get confused. 10 to the 6. That's one whole number. Micrograms. All over 1 times 1. Okay, now, in order to put this in your calculator, this right here, this is a number in scientific notation. In scientific notation, that means that you're going to have to find, you have buttons on your calculator for scientific notation. Some buttons look like this. Some buttons have something else on them and say EE above them, especially if you have a TI graphing calculator. Some of the Casios, like the one I like to use, has a button at the bottom that says EXP on it, and I've seen a lot of calculators that have a button that looks like this. Okay, take a moment and figure out on your calculator which button do you have. If you have a smartphone and you've turned it sideways to get the scientific calculator, some of them have EE button. I have seen some smartphones that have this instead. That's not natural log. That is actually your exponent button. Okay, so how do I use this button to enter 1 times 10 to the 6th in my calculator? Okay, I would push 1 EE 6. That's it. I don't push times, I don't type in the number 10, and I don't use this button. Some of you have a power button, to the power of. Okay, the reason is that this is in a very special format because it's base 10. And the calculator then wants this in the base, since it's a base 10 format, it needs you to use one of these buttons. Now, if you're using 3 times 5 to the 2, then you couldn't use these buttons because these are only for base 10, which is what scientific notation is. So I'm going to put this in my calculator. I'm going to write the answer out here. I want you to put it in your calculator too. That way you can check your answer and see if your answer is like my answer. If your answer doesn't look exactly like my answer, please come find me right away and show me how you're inputting your problem into the calculator, and I can help you make sure it gets set up with your calculator properly, because I don't want you to get points taken off because you know how to set up the problem. You kind of figured this out, but you're having a problem if one of these things appears. All right, so I'm going to put in my calculator, so I have 750 times 100 times, I'm going to push 1 EE6. Okay, and my calculator says that that is equal to 7.5 times 10 to the 10 power micrograms. This is such a big number that my calculator has to put it in scientific notation too. We'll talk more about scientific notation shortly, but just know that scientific notation is a shortcut for removing a bunch of zeros. It's a different way of just showing a number so that you don't have to write out a whole bunch of zeros at the end or a whole bunch of zeros at the beginning. And if you're calculating really big numbers in your calculator, it will automatically sometimes give you the answer in scientific notation just because it doesn't have room on its display to show all the numbers for the answer. So whatever your calculator shows, go ahead and write that down and make sure that you bring that to me if you're running into anything in your display you don't understand what it looks like. Make sure you come and talk to me and show me this before you go and grade your homework, and especially before you take your mastery quiz. Okay, I'm going to run through one more very quickly problem, like the ones that like this one where you have 2 different prefixes. Okay, again, the base unit here is the liter. There's a deci, this is D for deci, and kilo. Rewrite the number and the unit. 2 prefixes, 2 boxes. I need deci here, I need kilo here. Go to my reference sheet, deci, little d, 10 deci, 1 base unit. Alright, base unit is liter, so 10 deci, 1 liter. Let's write that very quickly. 10 deci, 1 liter. Kilo, 1 kilo, 1,000 liter. Okay, deciliter here, 10 deciliter, 10 deciliter, 1 liter, 1 liter. The unit here goes down here to cancel it. Here's the liter to cancel. This is 1,000. Copy 1,000. 1 kiloliter. Cancel out units. DL, DL, L, L. Cannot cancel kiloliters. Now set up to multiply. So I have 5.36 times 1 times 1 kiloliter all over 10 times 1,000. Okay, let's put it in the calculator. 5.36 times 1 divided by 10 times 1,000. That is 5.36 times 10 to the negative 4, or your calculator might show 0.000536. These are the same numbers in different format. Just kind of a quick note, if you're multiplying two numbers in your denominator and they're not ones, put a parentheses around them in your calculator. Otherwise, because your calculator follows order operations, it would divide by this one and then would multiply that answer by 1,000. Effectively, it would move this up into the numerator, so you're going to get an answer that's totally wrong. Okay. Make sure you come and ask me for additional assistance, and make sure you practice all of the problems on your worksheet and check your answers, and make sure you show your work. If you're having problems setting it up this way because you've learned the shortcut method with counting and moving the decimal, then make sure you come and talk to me, and I'll be happy to work with you.